Okay, so we want to keep reviewing Electrical Engineering 240. In this case, we are going to be reviewing Thevenin equivalent, Thevenin resistance. And since we're going to be doing AC Thevenin resistance, that means we're also going to be doing phasors. Okay, so we're doing AC, so that means we're using superposition and we're going to turn off our voltage, our DC voltage source. We're going to use phasors, and so this becomes minus J10. And so similar to what we can do before, you see that we have since this is shorted, then this is ground and our circuit can fold in half. And then we have a dependent current source. Since we have a dependent current source, we're going to come in here and use a test voltage of VT and try and figure out what my IT is there. Okay, so let's redraw our circuit with it folded and doing our phasor conversion. So we have 1 millivolt. We have minus J10. And then we have 40 kiloohms. We have 50 kiloohms. And we have 3 kiloohms. Now, when we put on our test source, we also have to turn off our independent sources. So we're going to come in here and replace that with a short. And here is our test source there. Okay, and here is our IB right there. Let me redraw. Okay, so when we have this piece, we could do a node right here. And when we do that node right there, you see that the sum of all the currents entering and leaving the node have to be equal to 0. So that means that there is no current. Let me change that to no current. If there's no current and there's no sources over there, then that means that IB has to be equal to 0. Because if there's nothing producing any current, there's not going to be any current. So now if we redraw our circuit, our dependent current source goes to 0 because IB is 0, and we have this. And you see if I put a test source with a 300 ohms, then the only thing I have is my 300 ohms. And so that means that my Thevenin resistance is equal to 300. And we are done.